Here we will draw an anatomic cross-section through the midbrain. First, label the bottom of the diagram as anterior and the top as posterior. Then label the left side of the page as nuclei and the right side as tracts. Next, anteriorly, draw the bilateral crus cerebri. Divide the center of the crus cerebri into the corticobulbar tracts medially and the corticospinal tracts laterally. Next, in the most medial portion of the crura, draw the frontopontine tracts, and in the most lateral portion, draw the parietopontine tracts. Next, we'll label the supplementary motor nuclei. Complete the basis of the midbrain, and on the nuclear side of the page, label the substantia nigra. Loss of dopaminergic cells in the compacta portion of the substantia nigra results in Parkinson's disease. Now include the tegmentum of the midbrain. In its ventral portion, draw the circular red nuclei just off midline. The red nuclei receive fibers from both the motor cortex and cerebellum and project rubrospinal fibers down the spinal cord. Lateral to the red nuclei, draw the medial lemniscus, and posterior lateral to it, draw the anterolateral system. Lower in the brainstem, these sensory bundles lie more medial, but here indicate that the midline position nuclei push them out laterally. Next, internal to the medial lemniscus and anterolateral system, label the trigeminal thalamic tracts. Now label the cerebral aqueduct as the cerebrospinal fluid space of the midbrain. Then label the surrounding periaqueductal gray area, and then the midline raphe nuclei, which run the rostrocaudal length of the brainstem. The periaqueductal gray most notably serves in the suppression and modulation of pain through opioid neuropeptides, whereas the string of raphe nuclei is primarily serotonergic and is heavily modulated by psychotropic medications. Lateral to the raphe nuclei indicate the reticular formation. Initially, the reticular formation was believed to simply be a diffuse arousal network, but now its functional specialization is well recognized. Now show the cranial nerve 3 and 4 nuclei in the dorsal midbrain tegmentum. Next, label the supplementary motor and sensory fiber tracts in midline, just in front of the periaqueductal gray. They are the medial longitudinal fasciculus, and lateral to it, the central tegmental tract. The medial longitudinal fasciculus is involved in conjugate horizontal eye movements, and the central tegmental tract forms one leg of the triangle of Guillain-Moret and carries reticular fibers to the rostral intralaminar nuclei of the thalamus. Now let's draw the tectum. First, draw the colliculi. Indicate the bilateral superior colliculi, which are involved in eye movements. They reside in the upper midbrain, and then the inferior colliculi, which are involved in auditory function. They reside in the lower midbrain. Next, draw the posterior commissure. The pathway for the pupillary light reflex passes through the posterior commissure, and the nucleus of the posterior commissure helps control vertical eye movements. Next, label the tectobulbospinal tract, which originates in the superior colliculus and decussates in front of the medial longitudinal fasciculus. Regional stimulation of the superior colliculus stimulates efferent impulses through the tectobulbospinal tract to the brainstem and upper cervical nuclei for head and eye movements. Finally, show that fibers from the superior cerebellar peduncle, the major outflow tract from the cerebellum, decussate in the central midbrain tegmentum. This concludes our drawing of the midbrain.